All right, let's pick it up where we left off. I was just about to explain elasticity of demand at price P. And so this is very closely related to what we've been doing with relative rate of change. Here is the question that's really driving this whole conversation. We're going to see a lot of examples with talking about price, talking about revenue. When will increasing the price of our product, let's say, also increase the revenue? So you would think, man, if you raise the price, then you're not going to be selling as many units of your product as you were when it was cheaper, right? If you ever raise the price, the demand, we say, goes down. But it's very possible to raise the price to be selling less units, but to make more money in the end if you raise it the right amount. What's naturally going to come out of this, it could be possible that you decrease price and you also increase revenue. So that's, if you lower the price, but then you end up selling more to make up for, even your drop in the price, you might make more money that way too. Your company might make more. So this is a really good question. We want to have, if we can analyze this with some equations, some definitions, that would be super helpful. Okay, so here's what we're going to do. We're going to define elasticity of demand at price P. We call it capital E of P. It equals the negative relative rate of change in demand divided by the relative rate of change in the price. So if we take the ratios of these relative rates, then we'll have what we call the elasticity of demand. Elasticity really just comes from the idea that changing the price changes the revenue. So there's this like flexibility that we can see in the revenue or even in the demand as we change price. And so sometimes revenue is not flexible. It's kind of fixed for some other reasons, and changing the price actually does not change the revenue. But sometimes, usually, the revenue is elastic. That means it's very flexible. As we change the price, it changes as well. It's kind of where some of those names come from. Okay. I'll explain why this is negative a little bit later, and it's really due to the fact that we want this final number to be positive when we're all done. So that'll come in a minute. We'll just say, okay, it's the ratios. What's the rate of change in demand compared to the rate of change in price? As I change the price, how does the change the demand follow? Does it follow a lot? It's very elastic. Does it not follow much? It's inelastic. Let's continue. Okay, so if we think of this, the relative rate of change in demand, well, that's what we've been doing. F, we're going to call the demand function. So we take the instantaneous, or the rate of change in demand, divided by the original demand, F prime of P divided by F of P. And we notice that's the derivative of natural log F of P. We're going to divide it by this. The relative rate of change in price is always as simple as 1 over P. If that comes from the natural log of F of P, this is the natural log of P, the derivative with respect to P, and just the straightforward derivative of natural log P right there, 1 over P. Okay, so we've got the ratios of these two relative rates. And if you go to simplify, well, if I've got a fraction over another fraction, right, I can take this one on the bottom and flip it and multiply it to the top. So the P ends up multiplying to the derivative. The 1 multiplies with the original F, and the negative, of course, carries along, and we get to this. There's the simplified version of the elasticity of demand at price P. Again, demand is the function F. That's how popular our product is, how much we sell per week or month or whatever we're doing. And then, we've got the ratio with the derivative. And okay, yeah, there it is. Now, why is this negative? Again, we really want the elasticity to come out positive. When we're all done, we want it to be positive. The demand, the denominator is always going to be positive. There's always a positive demand. But the derivative is always going to be negative. Why is that? Because as the price goes up, demand always goes down. If you raise your price, of course you're going to sell less than what you did before. So this is positive, price is always positive, but this is always going to be a negative because of the way that, like the slope will be going down, demand drops as your price goes up. So if that's negative, I want another negative here just to turn the entire thing to be positive when it's all done. Now, you are probably thinking, do we really, what's really at the end of the day? We just need to know the formula at the end of the day to perform the things that we're going to be asked. It's best if we know the reasoning and the logic behind our formula for EFP. But, in the end, know this, and then if you can kind of think further, then that's all the better, of course. Okay. So let's get into, we're not ready for our next example, our first example here. We're going to define, we'll kind of put that at the top. We're going to define what it means for different values of elasticity. So when we're done, we realize that our elasticity at price P is less than 1, we're going to call demand inelastic. It is not very flexible. As we start raising the price, the demand actually doesn't change much. And you think that's kind of bizarre. As I'm raising the price, the demand, there's really not much effect. Right? It's not flexible. It's not moving. If we realize this about our product, that'd be a great. We would love that, right? Because hey, well, if changing the price doesn't change revenue, then let's raise the price. If revenue doesn't change, but we're making more money, our revenue's going to go up. Our profits are going to go up. Okay. So we'll call that inelastic. Next up, of course, is elastic. If our E of P is greater than 1, then changing the price has a much bigger effect on demand, and it's probably what we would expect. Raising the price is going to lower the demand, but lower it enough where we're not making as much money. So raising the price, our revenue drops. Finally, it could be that your elasticity equals exactly 1. We're going to call that unit elastic. 1 is the unit. It's kind of right there in the middle. And it turns out, this is kind of interesting case. If we went to raise the price in that state, there'd be no change in the revenue. Raising the price, well, less people would buy our product, but because the price went up as well, it ends up perfectly balancing, and there's no change in the revenue. This is sort of like an equilibrium sort of a state. If we can get our elasticity to be unit elastic, we're actually maximizing our revenue. Because if we raise the price, there's no change, but if, at that instant, but we can't keep raising the price forever. We're saying it's unit elastic at a particular price. So if we were to raise it very much, our revenue would actually drop. If we were to lower our price very much, the revenue would drop as well. So it's like this perfect state. We found just the right price. So we're at that instant, we're like at the very top of the curve. And we have made the most that we can possibly get. Think of, like the slope of the tangent line here would be 0. We're at the very top of this arc. So if we were to raise the price at that instant, we're thinking the rate of change is 0. If we raise it too much, okay, I think I've said enough. If you want to read more about that, the textbook explains it really well, and they draw a nice curve illustrating how all this plays out. Okay, let's get into an example here. And I'm hoping you can see that whole thing on the screen. Let me zoom out just a little bit. Is demand elastic, inelastic, or unit elastic? And we're just going to do one of these for now. Let's say we've got x equals 1875 minus p squared. And we're going to look at this at price p equals 40. So they're going to present problems this way. Know that when it's x equals, that's f of p. So they're calling it x. That's the demand equation. But in our formula, we like to just think of that as our function of p. Okay, so let's kind of go through the steps to get everything we need to plug into our equation for E of p. Of course, we need a derivative. Pretty straightforward here. And so when we plug everything in, we've got E of p equals negative p times the derivative divided by the original. And then if we clean that up a little bit, and you can see, oh yeah, the rate of change in our demand is negative, because as price goes up, demand goes down. So those negatives cancel out nicely. Not too much to do there. Now we're going to look at this specifically at price 40. So let's plug in 40. And I invite you confirm that you get the same answer as I did. I got 11.6 for our elasticity of demand at price 40. And then, of course, the question was, well, was this elastic, inelastic, or unit elastic? Our answer here is bigger than 1, so that is elastic. Very elastic. In fact, 11.6. What does that mean? And this is just really the interpretation. We answered the question there. But okay, so if we were to raise the price, our price of 40, if we were to keep going up from 40, then our revenue is going to be dropping. And I would make the point that, man, if you're all the way at 11.6, that's pretty high. Your revenue is going to be dropping like a rock if you keep raising the price. But what if you were to do the opposite? What if you were to drop the price? Well, if it's elastic, that doesn't mean we don't learn anything. If we lower the price, then the opposite will happen. And our revenue, even though we're charging less, our revenue is going to be higher because we're just going to be selling so much more. So you'll get several questions like this. Is the demand elastic, inelastic, or unit elastic? That's kind of the mainstream question from this section. I want to end this video just by presenting this question to you. I'll give you a chance to work on it, and then we'll do it together in the next video. Find the values of P where demand is elastic and inelastic. Maybe we just know this demand equation. We're not looking at any one price. We'd like to know what are the price values that would cause it to be elastic or inelastic. Here, x equals the square root of 3600 minus 2p squared. Of course, that's what we think of as f of p. So I'm going to challenge you guys with this. If you are not sure exactly how to follow through to find those p values, then let me encourage you at least find E of p, the elasticity of demand function for any given price. And then maybe once you get that, then you'll know where to go. If not, we will be doing it in the next video. See you then.